Hello everyone, today I'll be going over Codeforces round 817, Division 4. And yeah, this was a really cool contest. There were a lot of cool problems, but unfortunately I couldn't participate officially because I had school, but yeah. So let's just get started. So in problem A, you're given a bunch of assortment of characters, and your job is to see if you can sort it to make the name Timur. And I'm not really sure how you pronounce it, so I'm just going to say Timur. And notice how in Timur's name, there's a capitalized T, and then the rest of the letters are lowercase. Well, it has to match this exactly. And I'll put yes if they do match, if you can scramble the letters to create Timur, and otherwise I'll put no. So I'm not going to go over my solution because my solution was kind of inefficient, but I thought of a solution that you could do after I solved it. Okay, well, one thing to notice is that you are able to sort strings. If you have an assortment of strings, like let's say C, B, or assortment of characters, such as C, B, A, E, C, if you sort the string, you will get A, B, C, C, E. And so it's sorted lexicographically, or alphabetically, I should say. Okay, well, after you sort them, you can always compare strings if they are equal. So let's say we have two strings that are a scramble of each other. After you sort both of them and you compare them, they will always be equal. So let's say we have the string cat. And then we also have the string T, C, A. If you try to compare them, they would not equal to each other because C does not match T, A doesn't match C, and T doesn't match A. That makes sense. They would both have to be cat, or they would both have to be taka. And so what we can do to check if they're a scramble of each other is sort both of them. So cat would be sorted to A, C, T, act. And then TCA, you can sort that too, and then it would also be sorted alphabetically into act. And now they're equal to each other, and this works. So just by sorting the strings and comparing those, you can check if both strings are equal to each other. And if they are, I'll put yes, and otherwise I'll put no. I will show you my code because I think I can just adjust it a bit, pretend something is something else, but this is my code. I overcomplicated it using sets, and you don't have to exactly know what they are right now, but yeah. What I would generally do is I would input n, input the string, sort the string using so if the string name is s, then or str, then str, or sort str. Actually, let me write it down on. Sorry. There we go. You can do sort str.begin, str.end. And then that will sort the string. And you do that with Timur, and then also with the input string they give you. Okay, so that's pretty cool. Alright, moving on to question B. In problem B, you're given 2 rows and then n columns. Vasya is colorblind, and so he can't distinguish green from blue. And you want to output yes if Vasya sees the grids to be identical, and no otherwise. Okay, well, one important thing to notice is you're only given 3 colors, red, green, and blue. He's colorblind with green and blue, meaning he can only distinguish red. So what can we do with this information? Well, we know that, hold on, let me delete this real quick. Okay, we know that if Fazia sees green on one side and blue on the other, he will think these are the same. But if he sees red, since he's not red colorblind, he can distinguish red from green. So he will notice that these are not the same. Okay, well, so now we can see that the only color that matters is red, because there's only green, blue, and red for the choices, and he's colorblind for both green and blue. So he only can distinguish red. So red is the only color that matters. We want to see if Fazia thinks that both rows are the same. And what we can do is we should only look at the reds and then see if they're equal on both sides. Well, what do I mean? I mean that if there are a bunch of G's, so G, G, and then GB, right now he will think both are the same because G is equal to G. G does not equal to B, but he's colorblind, so these will look the same to him. If, however, he has an R over here, and then a B, these are not equal because he's not red colorblind. He can obviously distinguish that there's a difference between the R and the B. The answer would only be no if both sides are not red. If only one side hasn't red. And this can be proven because for all other colors, they are equal to each other. But as soon as there's a red on one side, so like a red over here, and another color, let's say green, he can distinguish that there's only a red on one side, and then note that both rows are different. But if there are two reds, all will be well, because he thinks, or he knows that they are the same color. Okay, so now we know that the trick to solving this problem is figuring out if there's a red on only one side of it, and outputting no if that's the case, and otherwise, if all other pair of columns are either both red or green or blue together, then it'll be fine. So now let's look at the code. So I input the test cases, and then I get the two strings. You can input these as strings because they're a collection of characters. A collection of characters is a string. Okay? And as of now, we assume that the answer is yes. So when OK is equal to 1, it's yes. And then for each row, those are rows, right? No, for each column. If one row is red and the other one is not red, then we output no, or then OK equals to no. Or if this side is not equal to red and the other side is equal to red, then we also have OK set to no. 0 means false. 1 is equal to true in Boolean. So all this is doing is checking if one column is red and the other one isn't, and then just flipping it. And what this is this line is just a ternary operator, and it says if OK is equal to true, so if anything behind the question mark is equal to true, then we output the first operation, and if not, we output the second. And then the first and second operations are distinguished with this colon. Before this colon, so between the question mark and the colon, is if before the question mark is true, and otherwise you output what's after the colon. So yeah, it's essentially an if and else statement combined into one. Another way to write this line would be if OK is true, output yes, else output no. It just consolidates it. Okay, moving on to question C. So, 3 guys play a game. They write down n distinct words of a length of 3, and then they calculate the number of points each guy has. If a word was written by one person, that person gets 3 points. If a word was written by 2 people, each of them get 2 points. And if a word wasn't written at all, nobody gets any points. Okay. The main important thing to notice here is that each string is distinct, or each n string is distinct. So what this means is, if you have, so we're looking at this test case number 2, from 3 to CES. If you have an ORs on this line, you cannot have another ORs. So this QAQ will never be an ORs. ORs is distinct and cannot be repeated in the same line. That's really helpful in terms of finding the solution, because that expands the number of solutions we can come up with. So how do we solve this? Well, all we're trying to do is find out how many people wrote a certain string. Okay, well, what we can do is use the data structure I was telling you guys about earlier, the multiset. So what a multiset does is you can insert elements into the multiset. If you already know what a multiset is, feel free to skip this part, but if not, I recommend you to stay around because the multiset is an essential data structure. So you can initialize it using multiset, and then the data type, in this case, we're using strings, and you can name it. The name, I will name it set, or ST for short. Okay, well, how do you insert elements into the set? You use set name, so ST is the set name, dot insert, and then the element. In this case, I will insert S for string, or str. Okay, and how do you query elements? Well, one operation of the multiset is setName.count. So setName.count. What this operation does is it counts how many of a certain element there are contained in the set. So if you do set.insert str, set.insert str, and then set.insert x, well, set.count str would equal to 2, because str, the element, was inserted twice. Now if you do set.count x, it would equal to 1, because x was inserted into the set once. Okay, so now that we know that data structure, what we can do to solve this problem is input every single string into the set, and then iterate through every single string, and then see how many other people typed it. And if you solve for one line, it doesn't affect any other. And I'll explain what this means later. So now let's dry run the program using the first test case. So all we're doing is inserting every single string into the multiset, and then looping through the strings, and then seeing how many other elements are contained within the set. Okay. So let me leave that there. First, we insert A, B, C into the set. Next, it's D, E, F, and then another A, B, C. So D, E, F, and then another A, B, C. Okay, so that's the first step. The first step is to insert all the elements into the multiset. Okay, after that, we loop through each string in the line. So ABC is first. We do set.count, so we count how many elements are in that set, and we count ABC first because that's the first in the set. Well, ABC is there twice because there's one here and one here, so that's 2 total. So the answer is 2. And now that we know 2 people have wrote it, then we know that because 2 people wrote it, the current number of points is 1 for this guy. So let me write guy 1, guy 2, and guy 3. Okay. We know that since another person has it, and 2 people have ABC, 2 people wrote down ABC, then guy gets 1 point. Okay. Or it's 1, right? Yeah, it's 1. Now let's look at DEF because that's the next string. Well, if we do set.count DEF, we only get 1 because there's only 1 DEF written down. And since only 1 person wrote it down, the rules state that if only 1 person wrote it down, that person gets 3 points. So now we know that since Def is the only, or guy 2 is the only person who wrote down DEF, then guy 2 gets 3 points. Now going to the third string, ABC, again, it doesn't change from 2. Since if we do set.count ABC, we also get 2. Because there's 1 person who wrote down ABC, and then another. So that's a total of 2. And because it's 2, we see that it was written by 2 people, then that person gets 1 point as well. So the guy 3 gets 1 point. And we see that both guys wrote down ABC, and like the rules say, both guys get 1 point. So it ends up working. So that is just the solution. You insert it into the multi-set, and then you iterate through each string. So with a bigger test case, because I don't like how it's just 1 column. It doesn't really show the full extent to the algorithm. So in this larger test case, what you would do is insert all the strings into the multi-set, check this string, followed by the next string, then the next string, then the next string, and so forth. And then you just add the number of points to the respective line. So if it's line 2, then you add it to guy 2. Okay, let's look at the code. In the code, it looks very confusing, but a lot of it is just repetition. It's just multiplying it by 3 because there's 3 guys. But it's really simple, trust me. Let's go over it. So, actually, let me bring back the tab. Okay, so I represent each line as an array of a string. So the first line would be A, second line B, third line C. As you can see, first line A, so this would be A, the array B, and the array C. Next, I insert or input it, and then insert it into the multi-set. After that, I create a tracker to keep track of how many points each player gets. And then, finally, I iterate through each line. So this is line A, or guy 1, this is guy 2, and this is guy 3. And then I calculate the respective points. I set X to be how many of that element there are, how many of that string there is in the set, And if it's equal to 1, I add 3. If it's equal to 2, I add 1. And if it's equal to 0, so else, I add 0. And notice I don't have to type anything because that's a waste of a line. And that's a waste of time because since I don't add anything to it, there's no point in even typing a condition for it. So this is it. This is just the code. I'm pretty sure there are some ways to simplify it, but most of this is not complicated. It's just repetition. I'm just creating one for every line. Just inserting the elements into the multiset, and then for each string, calculate the respective points for it, for each guy. Okay, now let's move to question D. I found question D to be pretty fun. So you're given n people on a horizontal line, and they're either looking to the left or to the right. The value of a line is the sum of each person's count. For example, LRRL, we're looking at this case, LRRL. The sum of the values is 12, and here's why. This person, the first person, L, so each L and R is a person. So L is a person, the next R is a person, the next R is a person, the next L is a person, and so forth. So the first person, L, is looking left, but there's no one to look at, so that's 0. The next person, R, is looking right, and we know that is because it's R, which stands for right. And when it looks right, it sees 3 other people. So this is the person, R. When they're looking right, they see 3 other people. So that's why the answer is 3, or the value is 3. The next is 2, because this person is also looking right, and when they look right, they see 2 other people, L and L. And I think you get it by now. Okay, so what we can do is we can flip people over. So if this person is a L, we can change them to R. If this person's R, we can change them to L. And we can do that at most k times. And k changes every single time. So from 1 to n, we want to see what's the most k, or we want to see what's the highest value we can get by changing at most k people. So what does this mean? Well, in this test case, where the answer or where the string is LRRL, in the first move, we can only change it 1 time. Okay, let me draw it out. So n in this case is equal to 5, I believe. 1, 2, 3, 4, 5. Yes. So n is equal to 5. In the first move, we can only change it 1 time. Second move, we can change it twice. Third is 3, 4, and then 5, or n. In this case, it's 1 to n. Okay. So the first move, we can only swap 1 character. So we can only change one of these to their opposite, or at most one of these. And the second move, that character is already changed. So if we have LRRLL, that's kind of ugly. We want to optimize the value, and remember the value is like the count of how many people they're looking at. Okay, so in one move, we can change one of these characters, let's say R, into an L. So now this R has become an L. But we want to optimize this. So what is the most optimal solution? Well, we want to optimize the solution by looking at the farthest. So whatever's over here, we want to change that to an L so that it's looking at more people over here. If an L was closer to the left side, it's a waste of an L, such as this L on this side. This L looking left but there's nothing to the left. It's empty space because it's the first element. And therefore, this L's value is 0. And we want to calculate the total sum of all these values. Okay. So, how do we do this? Oops. Okay, there we go. So what we can do is we can go through each letter and then calculate the current value of each letter without changing anything. And then after that, we calculate what would happen if we changed something. Sort it, and then after that, we add it onto the total. So let me explain how to do that and what all of this means. And by the way, so when I say in the first move, what we do is change a letter, all we're doing is from 1 to n, we can change the direction of at most k people, which is the current iteration of it. So k is equal to 1, you can change the direction of at most one person. Okay, so right now it's LLR in this first test case. So we're looking at the first test case. You want to change the direction of the first person. So you want to change L to an R. After that, you would get RLR. And so the value goes from 1. And the value is 1 because if we check this, it's looking left, so that's 0. We check this next character, it's looking left, and there's only one character next to it, so that's 1. And the R is looking right, but there's no one to its right, so it's 0. So right now the total value is 0, or 1, sorry. By changing the first character to an R, you increase the value by 3, because now this R can see 2 people, and this L still sees 1 person to the left of it, which is this R, and so 1 plus 2 is equal to 3. In the next k, so k is the iteration from 1 to n, so now k is equal to 2, you can change the direction of at most 2 people, and now you change it to R. And now this is the most optimal. So no matter what happens next, since k is equal to 3, you don't need to change it anymore. So you don't have to change it. So it's going to be RLL. Okay. So an efficient algorithm to solve this is first look at the current value of everything. So the current value of this would be 0 plus 1, 2, 3 plus 1, 2 plus 1, 2, 3 plus 1, 2, 3, 4. 0 plus 3 plus 2 plus 3 plus 4. That ends up being 12. Right, that's a current value without changing anything. Well, in the first move, you can change one direction. How do we find out which person to flip? Which person to change the direction of? Well, we want to see which person would maximize this. And to figure that out, we want to look at everybody's options and then see how much, like the delta, and delta is the change. So we want to see the delta of their potential site minus their current site. So right now, R sees, or let me use a better one. Okay, right now L sees nothing because there's nothing to, and this is an L by the way. Right now the L sees nothing because it's looking left, so it's looking this way, but then there's nothing there. So right now that's why it's 0. Well, what would happen if we changed it to an R? If this were an R, it would see 1, 2, 3, 4 people. And so its delta would be 4 minus 0, which is an additional 4 people. It would see an additional 4 people if we change the direction. I'm not going to do it for the rest, but you can just follow the pattern and find the delta of the next character, the next character, the next character, and the next character. We would store them, and then we would sort them in non-increasing order, so in decreasing, meaning that the largest elements are closer to the beginning of the array. And then after that, we would add each element to the total value. We would add it to 12. So we would add this with the greatest delta. And the best way to show you guys, I think, would be to show you guys the code. So yeah, not too much code. All we're doing is creating the initial sum, or initializing the sum. If the character is equal to L, we add I to it. And the reason we do this is purely just pattern recognition. And the hard part of this problem is seeing a little off by 1 errors and seeing how to cancel the deltas out. And yeah, the first hard part is seeing like what to add, whether to add I or I plus 1, I minus 1, what. Well, we can see that we only add I because to find the initial sum, iterations are in 0 index. So this would be 0, 1, 2, 3, 4, because programming is in 0 index. L, since it's L, we know that it only sees 0 people. For this L, we know it sees 3 people because its iteration is 3, or its index is 3, sorry. And that's accurate. See, it's also 3 because it sees 1, 2, 3 people. And then something similar for the 4 over here. Since it's the 4th element, including the 0, so 0, 1, 2, 3, 4, we know that it can see 1, 2, 3, 4 people. Okay, so that's pretty cool. So now we got down what would happen if we add an L. Well, how do we calculate the delta for this? Well, the delta would be n minus 1 minus I times 2. And you'd be like, why such a cryptic algorithm? Like, what does this even mean? How do you get it? Well, if we break it down, we can see that all we want is the change in what we have right now minus what we could potentially get. Okay, so what we have right now is, or what we could potentially get minus what we have right now. So what we could potentially get is n minus 1 minus I. Okay, so let me rewrite everything over here. If we flipped this L to an R, so the first L to an R, that would create the value, that would make the value n minus 1 minus I. And the reason for this is we can see that n, or the number of elements, is 1, 2, 3, 4, 5. There are 5 elements, 5 people. 5 minus 1 is equal to 4. And then 4 minus I is equal to, in this case, 4 still. So looking straightforward would be 4. And yeah, that makes sense. You can see 1, 2, 3, 4 people. So that works. But why do we have another I? Well, that's the delta part. If we have other people behind it, so let's say an L and then an R behind the L I was showing you guys about, this L. Okay, well that changes stuff. N minus 1, now N is equal to 1, 2, 3, 4, 5, 6, 7. So now we have N is equal to 7, minus 1 is equal to 6. And now when we do 6 minus I, it's now equal to 0, 1, 2. So now I is equal to 2. And again, we're using 0 counting. So that would be 0, 1, 2, 3, and so forth. So this L is an index 2. 6 minus 2 is equal to 4. And yeah, that still works. That means we can see 4 people. 2, 3, 4. But this time, we're calculating delta. So we subtract another I. And all this is doing is removing the 2 that we have over here. So it's taking what we could potentially get, these 4, and then subtracting it from what we currently have, which is these 2. So removing another 2 from the 6 would make the 4, because 6 minus 2 is equal to 4, and then 4 minus another I is equal to 2. This would make sense because we are removing the L and the R, like the first L and R. So we subtract 2. And in return, we're gaining 4. So the net gain is 2. When we work with the rights, like the R, it's very similar, but instead we switch it. So we take I, because I is what we currently see, and then all we do is subtract N minus 1 minus I, because that's how much we can potentially see. Or sorry, I is what we potentially see, and N minus 1 minus I is what we currently see. And that will give how much we would see if we switched it. So this is how much we would gain if we switch it, and this is how much we would gain if we switch directions. So these are the same as each other, but with different letters. And you can work it out and see why. It's because what we could potentially see is I, because that's if you're facing left. So what we potentially see is our change of directions, like after the change of directions. Say now we're using R, let's say we're this R. A change of directions would mean what we potentially see now becomes I. So this is 0, 1, 2, 3, 4, and so forth. Well, I in this case is 3. And that's correct, because what we could potentially see is 3. 1, 2, 3 people. Okay. And then after that, we subtract what we currently see, which is N minus 1 minus I. Remember, that's 1, 2, 3, 4, 5, 6, 7. So N minus 1 is equal to 6. 6 minus I gives how much we currently see. I is 3. So 6 minus 3 is equal to 3. And that's correct. We only see 1, 2, 3 people. If we switch from the R into the L, we take the 3 that we got from seeing 3 people, and we subtract it with the other 3. And now our net total is 0. Or net profit, net delta. Because we go from seeing 3 people to seeing 3 people again. So nothing changes. And so it's pretty much worthless to change it. Okay. So after we add them into the vector called check, we can sort the vector check. And what the sorting algorithm does, the built-in C++ sorting algorithm does, is it sorts the elements in non-decreasing order. Meaning if we have 2, 4, 6, 1, 2, 3, we initially, with the C++ sorting function, by default, after sorting these elements, we would get 1, 2, 2, 3, 4, 6, non-decreasing order. You can see that it's like incremental. But to sort them in non-increasing order, which is the opposite, so if you sorted it in non-decreasing order, you would get 6, 6, 4, 3, 2, 2, 1. To get there, you have to use a third parameter called greater int and then 2 parentheses. So yeah, that's just a pretty cool thing to know. Yeah, so for each iteration, you want to add on to the original value the maximum of either 0 or check of I. And the reason we do the maximum of check sub I and 0 is because sometimes we have a negative net profit, net delta. So if we decide to go from, and I'll just erase this because I don't want to write it again. Okay, so if we go from, let's say, this L to an R, we change this L to an R, we go from seeing 1, 2, 3, 4, 5 people to seeing 1, the net profit would actually be a net loss. It would go from 1, 2, 3, 4, 5 to 1. And so the total net loss is equal to -4. And that's not good. We don't want to lose any. We want to maximize the value. So it's better to stay the same in this case than to lose the value. And that'll always be the case. So you would rather stay the same or add 0 than to lose something. So as soon as we're losing something, we want to set the value to 0 so we don't lose anything. We would rather gain nothing than lose something. And we know that the sum never decreases because the sum is always increasing. After changing a letter, like let's say we have L, R, R, after changing L, R, L, we don't reset back to L, R, R. This is our new string and we work with this. Now we can change L to an R. So we continue to adapt. This is why sum keeps getting added on and it doesn't reset. So yeah, that was problems A through D. If you enjoyed it, please leave a like and subscribe. And if you have any additional questions, feel free to ask in the comments. I'll be happy to respond. And yeah, thank you so much for watching.